And good afternoon. My name is Ray, and I'm a research student here in Washington University School of Medicine, specifically in Institute for Informatics. So today I want to present an abstract submitted by our lab. It's called Simplifying Clinician Supply Retrieval Experience with Voice Assistant, and we name it after Voice Connect S. So S here means supply, and we use Amazon Alexa as our baseline. So like I mentioned, Voice Connect is basically a voice application in healthcare. Well, to give you guys more background knowledge, so a voice app in healthcare is just an application that taps users' voice to power some sort of digital healthcare experience. So this project has really become doable thanks to the introduction of technologies like Amazon Echo, which give us offer us a hands-free way to interact with the information delivered through smart speakers. Well, the way people are using this technology is evolving for sure, and in our team, we also keep thinking about how we can make the best of this technology, which gave birth to this project. Well, the content today I want to work through is basically following the logic of our abstract from the research background, research method. Then I will briefly talking about our achievement and result findings so far, and the final part is our discussion. Well, let the journey begin. So the first part is about the background. So the problem our voice connect try to solve, our project try to solve is to improve the efficiency of clinicians to do supply retrieval. And the way we think of this problem is that clinician time is extremely valuable in a fast pace. Some non-productive tasks like gathering supplies, this time should be better consumed with patient instead of those supplies, right? And we know that our supply rooms are sort of different, and each division, I mean, in BJC supply room, they all carries high variable supplies in the supply room. So sometimes it's not even 100, it's more, it's like near 1,000 different kind of inventories in a single supply room. And we all know that clinicians, they need to like search for needed supplies to care for patients. And but this thing could be like particularly stressful in some urgent scenario with items used less frequently. And here's some data we gathered from field research and from like the observation. And you can see from the first bubble, it's actually the result of our time motion study done on nurses. And we found that each nurse, like they spend around 30 minutes of 12 hours on supply retrieval. And the rest of the two bubbles, the result we observed from the safety report, BGC and BGH. So you can see in 2018, there are 90 safety events related with like inadequate supplies in BJC, and there are 29 kind of similar events happen in BJH. So these numbers are exactly what our project trying to deal with. And the solution we think can handle this problem in a nice and easy way would be to just have voice assistant over there. And we imagine that by finishing development and installation, our voice assistant could achieve this. Like if clinicians have something they need in supply room, they barely just need to ask, and then our voice assistant should be able to tell them where to go, where to find an item they want. And if this could happen, it could potentially also streamline supply retrieval process for clinicians and reduce some time they spend in supply room. And of course, to do this, we need to make it like easy to use and like make clinicians satisfied with the conversation experience for them with our voice assistant. Here we actually designed three kind of like measurement just to measure the performance of our voice assistant. You can see the first one is the accuracy is for sure because you think that the way you want to use Alexa would be like it can answer your question like quickly and accurately, right? And the second measure, we want to find like how much time our voice assistant could actually help clinicians to save. And the third one, we want to say whether clinicians are happy with our, you know, voice assistant. Well, but today on today's presentation, I'll just focus on accuracy because we're still in the developing, developing period, and we haven't like change our focus to time spent and satisfaction. So in our current state, we basically just focus on accuracy to improve the accuracy of our voice assistant. Well, with that in mind, so how are we gonna build it up piece by piece? Well, it always start with like first to choose the software development. The thing is that currently there are like many kind of open source platform for us to develop a voice application. For example, we have Amazon Alexa came in 2014. That's almost the same time with Microsoft Cortana, and we also have Google Assistant that published last year, 2018, and we also have Big Spy by Samsung and AliGenie from Alibaba. So that's quite a few choices. And after we done some comparison, we compared like software development and environment, and we compared the safety issue and also database connection. We finally locked down Amazon Alexa as our final choice of like development platform. So after we have that, we need to find our data home, right? So by saying data, I mean the data of various kind of supplies. Specifically, the supplier's name and their location. Here we actually use a bin color and bin number to specify one specific location of that item as, and that's the language we use. And for a home, I mean the database, right? So we think that we may just use, since we use Amazon's Alexa, we may just use the database provided by Amazon in order to achieve some safe and quick, data transfer and querying. So DynamoDB, that's the name of database we use. It's from Amazon, and that's why, and that's what we basically that's why we choose it. And once we have like software development environment, we have our database. Now what? We need to find something to actually measure, or at least we need to find some like process to measure the performance of our Alexa, right? The thing is, we don't want to put too much pressure on achieving everything to get a perfect result at once. Actually, we want to first develop a draft version and then improve its performance gradually. So we come up with a three-stage acceptability testing, and it works as follows. So in the very first beginning, we do some preliminary development. So that's basically just based on our intuition experience. Like we were thinking about what would happen in the inventory room and what would the clinician say if they want to get some help from Alexa. And then after we have done our like first period of development, then we tested with our brainstorm scenarios and like our simulated questions. And then in the stage two, we actually did some Redcap survey. It's basically we just went to a supply room and collected some like real life dialogues. And if you have dialogues and use scenarios. So if you have been to 11 supply room in the 11300 and 11800, you should probably have already met Mickey, Sierra, and Brainy. So they were our team members, and they were there to interview clinicians and collect some dialogues, like what would the clinicians say if they want to get help from Alexa. Well, after we have finished those Redcap survey, we basically test our Alexa again and improve its performance based on those real life dialogues. So and that's current. We are currently at the end of the stage. We're at the status at the end of stage two, and in the coming stage three, we're gonna do some pilot testing to supply room and collect feedback from clinicians. So next part I'm gonna dive into more details about like what we have found and what's our achievement during the past two stages. The first I want to mention one thing we found during the Redcap survey. It's actually not one thing; it's two things. One is called sentence structure and the sentiment table. That's based on our analysis for those natural dialogues we collected during Redcap survey, and actually find that in the real life scenario, each clinician they may use different ways to ask for Alexa services. Like some people will use Alexa, where are something, or some people use where can I find, or can you find me, or even sometimes they just want to like name it directly. Actually, we want to like our Alexa to be able to handle all this different ways of asking question, so it can make its own system more robust. So we done some like analysis on those dialogues, and we find there are 6 different kinds of pattern for question asking. Like we have where question, where it's like where are or where is something currently stored at. And there are also weird question which was asked in, which is asked in a more proactive way. And there are some like closed question, like can you find me or do we have? Although it's a like closed question, but actually can you just need more answer than just yes or no. They actually need the location. And we also have some direct commands like give me something or please give me, and we also have like name directly or so. That's basically what we have find on sentence structure, and after finding that we improve our like voice connect and armor it to handle this kind of scenario. So it currently can do all these kind of different scenarios, can finish all. And the other thing we find is like a synonym, right? We find that for one item, actually in the daily use, clinician may use many different kind of synonym of the same thing. Uh, and after we find that, we did some further research because we think it's very important. Because the way Alexa will help you is always start from like Alexa will recognize the thing you want, right? So it can connect with database and find the thing. We basically went to a supply room and we interviewed with more clinicians and asked them question about synonyms. And from the result we collect that that's more than 800 different items, and we found that almost all of them have at least one synonym, which means they have at least two expression for which means item have at least two similar two kind of expression for the same thing, and some 33.8 they will have two. And after we've done that, we built this up, built this cinnamon table up. You can see first the thing like a Tinkerderm. Actually, some clinicians call it average dressing, and some people even call it like transparent dressing. Yeah, they all mean the same thing. So we finished the cinnamon table, and then we upload and merge it to our kind of version of Voice Connect, so it can be able to handle all those kind of different names and different synonym names. It's kind of difficult to collect and admit, but the result for done this is quite rewarding. And the next part is kind of our major like finding or major achievement. It's something called multi-hub interaction model, and it's actually just a communication model used to handle different kind of questions asked by users, by clinicians. And by saying multi-hub, it means that it's not just one question, one answer pair. It's kind of like a conversation, and it won't end until users' need is satisfied. It tried to make the conversation, make the question answer not stop. I'll give you an easy example to understand this. So, for example, if you want to hear some joke from Siri, I would assume most of you have experience of using Siri. You'll probably just say like, "Hey Siri, could you please tell me a joke?" And most of the time, Siri tell you a joke, and you'll find like, well, most time it's not even joking. It's just sometimes code. And but only a few times if you find like Siri did a good job, and you want to say like, "Hey Siri, I like it, I love it," or "Siri, I love this joke," and this time Siri won't know what do you mean by it. What do you mean by this joke? It's already forgotten the joke. He or she, the Siri, she just told you several seconds ago. So this is quite disappointing, right? And we figured that in order to make this interaction model, conversation model, happening, we need to give our Alexa a little bit longer memory. Yeah, in order to achieve this multi-hub interaction, achieve this conversation. So, and the real conversation would be like this, like what we shown us here and in this flow chart. It's always start from the clinician say like, "Hey Alexa, ask Voice Connect where is something, like where's the syringe." And after that, Alexa will try to recognize the item you want to find, and then it will go to database and check whether it currently has that item in the supply room. If it has, it will then move to the next step. But if it's not, it will try to give some feedback to clinicians. But yeah, there could be some mispronunciation that actually it has this thing in the database in the supply room. It's just like because some mispronunciation that Alexa didn't get what you said just a few what you said. And then Alexa would like to ask you to say it again. And after you say it, Alexa, hopefully it can recognize it this time. and then it will goes back to the database and try to find where that thing is. And but if, sometimes you may offer incomplete information. So incomplete information here means that, for example, for syringe, have different kind of size comes with it. So if you just mention syringe, but you didn't mention size there, and different size of syringe, they actually stuck at different kind, a little bit different kind of bin color and bin number, different kind of bin number. And Alexa would ask you what kind of size would you want. And after you provide that information, Alexa will give you the accurate location. This is kind of the normal ending of the conversation. But if you actually go there and you find the things not there, uh, this could possible. Yeah, this thing is possible. It could be it's running out, and you would probably want to say, "Hey Alexa, I go there, I went there, but it's not there." And this time Alexa know what do you mean by it. That's the kind of that's a supply you just asked about. And then Alexa would give you some back option like the nearest supply room had this thing is blah 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 like room 3 or room supply room 2. Yeah, but if the near even the but if the even nearest server doesn't have this thing, Alexa would basically tell you just to contact supply management office and ask them to help you. This is kind of the real ending of this interaction model. Well, this is kind of sounds like an easy thing, but there are kind of like a lot of technical details comes with it. And since time won't be enough, I'll just like quickly go through the slides. So it also starts from clinicians say some word to trigger like the services, and in developing all the skills combined with Alexa, we actually divide it into two parts. So here we call it front end, back end. So front end is like we let Alexa to tell what kind of a thing the clinicians want. So here we have clinicians may have several different kind of questions. They may different kind of thing they want. For example, if the clinician say Open Voice Connect, we call it something like a launch request. It's because the user want to open it. It's like when you want to use Safari, you need to first open Safari. So we call it a launch request. And if the user want to find something, actually that's a main function of our Voice Connect. We have something called item search intent. And then we have some like help intent, cancel intent, and emergency intent. These are basically provided by Amazon, and we just use it in case of something happen, emergency happen, in the supply room. You may want to call 911 or so. And that's more our front end. That's just this front end part is just used to to tell what kind of request this user currently want. And then you will transfer this information back to our backend. So backend here is really like programmers, do some coding work to handle the front end question. And and specifically for each kind of intent or request in the front end, we have one specific handler to handle the intent. For a launch request, we have a launch request handler. For item search, we have like a search item intent handler. Yeah. And during this process, our backend Lambda function would also try to connect with DynamoDB, our database, and get back to the location information. So this kind of our technical details. And things I mentioned, we just currently at second stage, and actually we are currently in second stage plus, stage 2 plus. So that's basically after testing with some real life dialogues, and also we done some data analysis, and we build up some synonym table, and we build up synonym table, and we merge those things into our current version of Alexa. So that's why we call it the stage 2 plus. So you can see that the accuracy performance of our Voice Connect, from 75% in the stage 2 to 99, almost 99% in the stage 2 plus. So it can handle almost every kind of question or scenario happen in supply room. And in the coming stage, we will also through pilot test, we will still keep track of Alexa's performance and also make some continuous improvement. This is kind of the so next part is conclusion. So this basically like our thoughts and ideas, and our analysis, after we've done so many work, and what we thought of our project. Especially we think that our current version of Voice Connect, you can effectively capture clinician's request for supply retrieval, and also it can reduce clinician time spent on supply retrieval, and also it could increase clinician satisfaction because we think it's easy to talk with, and also it could potentially streamline supply inventory management at BJC facilities, and also improve patient care quality and safety. Now, this is kind of our end of the presentation, but since we mentioned a lot of like matrix, a lot of skills in of our like some of our voice connect, it would be a big pity if we just talk about it, right? So so the final part, how about we meet her before the end? Well, in this part, I'll try to do some demo, like how would we people want, what would happen if people are talking with Alexa on some like item search question. If the internet, if the Wi-Fi is good, Alexa should be able to give us some feedback. Yeah, I would. Yeah, let's see. Mm, so, hi Alexa, could you please open Voice Connect and briefly talk to us? What you can do?
Hi there. I can quickly help you find any inventory current stocks in this supply room, or a nearby room. You can name it to let me help you.
All right, we can see Wi-Fi is good. Yeah, so Alexa should be able to handle our question. So I'll just think about some item that Alexa to search for us. So hi Alexa, can you help me to find the nasal trumpet?
There are two sizes of nasal trumpet, 28 and 32. Which one do you want?
Yeah, I want 28.
Got it. They are in green bin. Number 3.
All right, so now I get the information. So it's in green bin number 3. This is usually the end of the conversation. But will the thing happen? Like I just said, that the clinician go there, and but it's actually not there. So I'll just ask Alexa again. So hey Alexa, I go there, but it's actually not there.
Sorry. The nearest room has this item as inventory room 2. You could go there to find it.
All right, I'll go to inventory room to find it, and hopefully when I get there, there's also an exit help. So yeah, this part after we done this demo, this is really coming to the end of our conversation. But I'll just ask Alexa to say if this is the end and whether she has more thing to add.
Yes, the presentation is finished. But I can't see any hands because I don't have visual skills yet, only auditory.
Yeah, all right. This time I'll help her. So if you have any question, please raise your hand so I can know, and then I would like to let us know so we can be there to help you. So thank you again. So this is the real official end of my presentation. And for all my team members, thank you again. Thank you to Fan Xiaonan, Sierra, Brainy, Nikki, Nicole, Albert, and our co-PIs, Ling and Boeing. Thank you very much. This project couldn't be done without your contribution and help. Now we're here for any question and